the MOSFET that is misbehaving. There is now a board. There is one thing here that we call MOSFET driver. This particular one. What this MOSFET driver does is that it makes sure that each of those MOSFETs are working perfectly. About my system. Are you guys with me? Sometimes you might have 6, like this designer, they have 12 here, 12 here. So 3 is handling going up, another 3 is handling going down. It's formed like, let me put it this way, let me draw the way. Let me say this is a sine wave. Right? Sine wave, be complete sine wave. This first 3, you handle it to go up like this. This second 3, you bring it down like this. This other 3 here, you bring it down like this. This other, there's another 3 here, you bring it up like this. Somebody, these 2 ones, they are very thick wires because high current long gbebo to convert to high voltage. These 2 are very thick. Whereas these 2 ones, the one that supply here, are thinner. This one is to power output here, while this one are to power the battery. So the MOSFET driver, what the MOSFET driver normally does is that it will now regulate all the activities of those ones going up and down, all the 4 ways. The moment you notice that someone comes and says, my inverter is working, but by me, most times the silent MOSFET driver is behaving, or some of these MOSFET has faulted. The third part that we now have in an inverter, you know, I've talked about the charging part. I've talked about what? The inverting part. We now have the processing part, or we call it the switching part. It's on this board. That's where you have the switch, the switching part, and it is all this IC that does the switching function. Can I move on? The switching speed now, what does we mean by switching? You know, let me explain this way that you know, sometimes when the power being sliced and your generator is running, there are some people that to check. Inverter has a switching speed of more than 0.5. Means that within 0.5 seconds, when light goes on, you switch back from here to here powering it. So we get what I'm saying. You know what? Energy comes in, enter battery. The moment the energy is not coming in again, battery quickly supply it out. So the switching between that, this is what I mean. That's a normal inverter. A normal inverter will have a switching speed of switching time of 0.5 seconds. Next after that, we now have some inverter that switch lesser than 0.5. We normally call those ones UPS. When you see inverter that they write UPS on it, uninterrupted power supply, meaning that the moment the light goes off, you will not even notice that light goes off at all. It's less than 0.5, pam, it has picked up. Most of these pure science inverter nowadays, they are UPS inverter. That is, the moment light goes off, it will switch by itself. The third type that we have, we call those ones online inverter. Like the type that I use as machine tools. They use it for where you have internet servers that light must not go on them at all. They have a switching period of less than 0.1 seconds. Your normal UPS will have a switching period of less than 0.5. While your normal inverter has 0.5 and above, greater than 0.5 and above. Let me get what I'm saying now. If it is more than 0.5 seconds that is switching from here to here, is your normal inverter. If it has less than 0.5 seconds, is UPS. And that's why I normally advise when you're installing from the normal private house. The moment light goes on, they don't even know that light goes on. Speak up. There is no need of changing it. You can put the change over there for 5 hours. If we want the inverter to quickly charge, you are still coming to that. If inverter is working while it's charging battery, it will not charge as fast as you are normal on your normal electricity and the inverter is working alone. I'm talking of light goes up like this, you don't go to change over. You want the inverter to switch. So the moment the switch was less than 0.1 seconds, and another thing about online inverter is they normally have Ethernet port where you can connect to their board and you can program it to maybe reduce or increase the time. You have an IP address where you can log into it and check. This switching time is 0.2. I want to reduce it to 0.1. And we basically use those ones when you are working on internet setup, maybe server or a gaming center where if the game goes off like this, they will need to restart again. Use online. But if it's not that, you don't need online UPS for a private house. A good example of company that produce online UPS, we have Felicity. They have online UPS. SMS, they have online UPS. Sign, they have online UPS. Daye, they have online UPS. But most of Afri Power what's the name of this one? Where is it called? For Solar, they don't have online UPS. They only have UPS and inverters. Because someone might ask that, they call some UPS, if you use UPS on system, you don't even notice that light goes on. If you use ordinary inverter on some system, you see that it will flake. So the three parts that it has the charging, it has the discharging that we also call the inverting part, and it has the switching part. There are some times when an inverter is not working very well. We call this one smart charger, or we also call them rectifiers. These rectifiers, these two thick wires, they are DC. Let me explain a little about rectifier, although we will still come back to it. These two parts, they are AC. You see this one that we take separately is positive, is live and neutral. Why this one is positive and negative? Hey, you don't go see that one. Where do we use this time? If, let me say this inverter now has a charging amps of 20 amps. 20 amps means that if I put 20 amps battery on it, it will take 10 hours. Daddy Khalid, ẹjọ́ àwọn online ẹ wọnú class wa díẹ̀ díẹ̀ ẹjọ́ ẹ má bínú. The 20 amps on an average means it will take 10 hours for your battery to be full. And there are some environment that you know that they can't have 10 hours of electricity. Maybe they are having 5 or 6 hours. And you want your client to charge faster. And you don't want only this to charge it. You can use this rectifier. If you want specification, this is what they do. This rectifier can supply up to 50 amps. So just imagine that you have 50 plus 20. Make it 70. Within 3 hours, your battery is already full. If you use this rectifier, instead of using 9 hours, within 3 hours, if you use this one, your battery is full. Man, the moment this àti ẹ̀yí báyìí ẹ máa run wire àti ẹ̀ lọ sínú ground, so shocking kìíní tó ń shock yẹn. The way you normally look at me when I'm speaking Yoruba, the excess current that is radiating here will sink it to the earth. So we normally use this when you want your battery to charge faster. Let me just talk a little about it because I'm talking of the charging part. I'll still talk about it later. It has an advantage within 3-4 hours if you have electricity on your generator, your battery is full. But it has some disadvantage. Your battery, just imagine, me I'm working, you are running. The person that is running, you get tired before the person that is working. Although the person that is running will get to that place, destination.
It's not easy.
The person that is running will get there faster. But to get there,
will be tired.
The person that is walking will also get there, but will not be tired. Same thing with this rectifier. When you use rectifiers in a circuit alongside with your charger, your battery will charge faster. But a battery that has a lifespan of 4 to 5 years will not spend up to 4 to 5 years a day. Your normal maintenance should be 6 months. Will be shortened from 6 months to 3 to 4 months. Because the moment you charge off the battery, the water will start going low. You will notice this from the distilled water. The water goes lower and faster. So if you are having a 4 battery system and you should use between 15 and 20 liters in 6 months, you must go there within 4 to 5 months. Maximum of 5. Even if you don't go there by the 5th month, they will have started complaining to you that the battery is not lasting as long as it's used to. But when you fill up the water, so it makes your battery to charge faster, but at the same time it makes your lifespan of your battery, it will reduce the lifespan. Number 2, it increase the period of maintenance of your battery. We still talk about 35 later. Let me just stay on the battery now. Then we now have something we call load. Don't mind me that everybody is standing. I mean, we should go and sit down now. We are through this one. Let them go to school and back and sit down. Let's sit down back. I'll see what we have to say. Everybody is sitting now. So we are ending this class by 12:14. We have what we call load, as I said earlier, and we have what we call load capacity. If you want to, how many? Don't let me ask how many of us is drinking beer here because we are online. Under your energy, your electrical energy, we have what we call the reactive energy. We have what we call the active energy, and we have what we call the total energy. Active, reactive, and total. I'll be writing. For my total energy is measured in kVA. So if you see them write 3.5 kVA on an inverter, the total energy that this inverter will generate is what? 3.5 kVA. Let me ask you a question now. If you carry your beer and you pour it inside the beer cup, the bubbles at the top, will you drink it? You can't drink it now. You only drink the liquid. The liquid that is a usable energy is what we call the active, or the usable energy is measured in kW kilowatts. There are some inverters, like most hybrid inverters, they will not write it in kVA. They can write 4,000 watts. Oh, inverter tuntun tó wà ní pálí ẹgbẹ́ wa GA ẹjọ́ lọ́gbẹ́. They can write this inverter is 5 kVA, but what you can use there out of this 5 kVA, what is available to use, they might say is 3.5 kilowatts. Let me check the data. Ọ̀kan gbé jáde ìgbà àti ẹgbẹ́ sórí bíbí ìdí ẹ̀bá yìí. Ẹjẹ́ mo ta ìdílà so that I'm a very young let me see if I can show you guys. You will see this inverter is 5 kVA, but the energy that it can put out is 3.5 kilowatts. The peak charging, the energy that it can absorb inside is 10 3.5 kilowatts, meaning that although this thing is 5 kVA, what I can use is 3.5. 3.5 minus 5.
Nice.
So 1.5 my waste.
Why is it because it's ice?
1.5 is reactive. Heat new. Transformer new. MOSFET new. Those are the energy they will consume and waste stuff. So if I'm using this inverter now, I might take this in one carton asthma, most of the if I'm using this, that's why the inverter is 5 kVA. All the wattage I'm calculating must not exceed 3.5 kilowatts. So that's for that 3.5 kilowatts, this inverter will be shutting down. There is now something that we call power factor, PF, power factor. That power factor is the ratio of your total energy to the energy that is available for use. Tabani emu phone yìí ẹgbẹ́ 5 divided by 3.5 3.5 over 5 ẹ calculate it. There are some inverter they write 6 kVA on it, but what you can use there is 5 kilowatts. Oh yeah, I share mathematics there. And then because there are some people they will say 5 kVA inverter dem mo lo le yen o. Somebody wa tan na. Inverter dey shut down. Gbogbo load to dey wa be to 5 kVA. There is a difference between kVA and kW. Some inverter has a power factor of 0.1. So 5 divided by 3.5 over 5, 0 point something.
Yeah, dividing.
3.5. Bring your phone, let me check.
0.7.
So, 0.7 of your energy is what you can use. And the power factor is 0.3. 0.3 of anything that you are calculating will be wasted. What do I get what I'm saying now? There are some inverters that they are 5 kVA. That instead of 3.5 that is available, it will be 4 kVA that is available. The power factor will not be 0.3 again. The power factor will be like 0.2. The power factor is your available energy that I can use over total energy minus 1. If it's a pure hybrid inverter, they will not even put kVA there. It's the energy that you can use that they will put there. They might write 5 kilo. That's why you normally see some people ask me, 45 kilowatt, 45 kVA, or get one king and bed. The way you always look at me when I see you is the available energy for use. So as an installer, what you actually need is the available energy that you can use, not the total energy that the inverter can produce. Let's now move a step further. That my car can run. I'm still on inverters. I'm just doing like a refresher for those that have the knowledge and a comprehensive for those that doesn't have knowledge. If I have my inverter now and it's 5 kVA, can I use all the 5 kVA? Or let me now move to kilowatts now. I have the total energy that I can use on that inverter is 5 kilowatts. Can I use all the 5 kilowatts? Most inverter has tolerance level. That your car can run at 260 km/h. Does it mean that you will be running on 260 km/h every time? One of them are budget. Are you know about accidents? Are you guys get what I'm saying? So, meaning that my inverter is 10 kilowatts. That doesn't mean that I must have to make sure that all the load on it is 10 kilowatts. That inverter it will work, but it will not last. We need to put tolerance on it. Me, I normally make sure that all my load will not be more than like 70% of the inverter capacity. We will still come back to the calculation if we have the time today. Mean that when I calculate the total load in that house, I now discover that the total load that they want to use in that house is, let me say, 2.6 kilowatts or 2,600 watts. You know, some people say, let's use 3 kV inverter. I don't use that. Because a day may come let me assume that the breaker, it escaped the breaker, and they just suddenly go and plug an iron or 500 watts down on the inverter. I guys get what I'm saying? You know, some days you might just put on fan, maybe you have full house, maybe they have wedding, and everybody is around. All the rooms they put on the lights, all the socket they are charging phone. As they are charging phone, some are playing games. There might be days that the load will be more than what you have already calculated. And the funniest thing about life is there was a job I did like that. I told the guy, let us use 4 kV. Only around, because he's also an engineer. So we did the calculation together. I don't let him say the location because so not about share only about one. Don't let him say the location we did the job. Just no, let's use 3.5. They now have a ceremony. As the instrumentalists came, they just plug everything on the NEPA. The one NEPA goes up like this, they switch inverter like this, the inverter shut down. They come and say, the inverter shut down. I rushed down there. When I got there, I said, oh yeah, remove the instrument. The moment they remove the instrument and put it on, the instrumentalists, those musicians, they came with their own generator, but they want to save energy. Everything start working normal. And I said, Aki, but I said, our calculation was 3.5. The moment they put this load, there's over 1,000 to all the light that is on here. It's not put on. Because then they now said we should upgrade that inverter. Do you guys get what I'm saying now? So when you calculate your load, it's very rare that your load will not be 3,000 watts. It might be 2,800. It might be 3,200. Make sure just calculate tolerance that if the load there is 3,200, let me use 4 kV or 3.5. Let me use 5 kV. Are you guys hearing what I'm saying? If the load in that house, maybe I'm a student, the total load, there's an institution that I did an inverter there. Everything they want to be on that inverter was just the server, the gates, and the electric fence. Their need is around 900 watts. But I've emphasized that some days might be. And actually later they started putting on their main system on the inverter line. So I put 1.5 kV again. I get what I'm saying. So any day they use beyond that scope, although we are still coming to how we calculate it, that the type of breaker that you use, the moment you now go beyond that level, instead of everything to fall back on the inverter, the breaker will blow up, just keep up. There was someone that called me this morning and we were discussing on breaker. He's my guy. When he's already an engineering graduate, I was still looking for admission. But you know, we have life experience, we have field experience. Based on his calculation, he went ahead and used 63 amps breaker. So anytime the amps is more than 63 amps, the breaker will do what? Collapse. Initially he was saying, the breaker keep collapsing. I'm not the one that, he was the one that did the job. I don't say, sir, okay, let's change it to 120 amps. That when they call 120 amps, the inverter is 10 kV. You can still handle that 120 amps. You now call me today after a year and say, Akinlusi, that we have changed that breaker. That thing has been working perfect. Oh yeah, that's what I'm saying. Why am I trying to say this? It's not only you increase the capacity, you must also have a breaker now. The moment they now use load beyond the capacity you have calculated, instead of them to end up calling you that the inverter has spoiled, it's better that the breaker will even spoil. And go and change breaker, maybe 8,000 or 10,000 or any amount they sell it. That's how I get what I'm saying now. Another thing I want to talk about this inverter, I've said it earlier, but I want to repeat it again, is when your inverter is in inverting mode, it dissipates a lot of heat. So your fan must be working. There was another job that we did in Ibadan. We have 2 fans there, the sucking fan and the blowing fan. One of the fans collapsed. Do you know one funny thing? These people, this is their own behavior. They go to work very early in the morning, around 8 a.m. They have leave their house. So before 8, you know that sun, you know, it's not yet out. So the weather is still cool and one fan is still blowing. In the evening, they will come back around that 6. The weather is also cool. But they now have a complaint every time when they are not around on weekends. Maybe Saturday they are not at home. By the time it's around 12:01, the inverter will start writing SSs. They go and put it off. They wait for like 1 hour. After 1 hour, when the motor is cooled down, the moment they plug it back, it will start working back again. What is the solution that we did? It was Timothy that went there. We just went there with an alternating current fan. You know, this one is direct current. In alternating current fan, we just connect it with the output. The moment the inverter is on, the second fan is off. Okay, it's the man that just came a few minutes ago that I saw that fan. And there's one advantage of those fans. If you put it this way, it will be a blowing fan. If you put it other way, it will be a sucking fan. So it can serve both ways. I didn't know the funnest is you put that fan there, the inverter. So I was factoring that if we need to change that fan, okay.
Was the fan having a problem?
One of the fan is having problem. And if I'm to bring the inverter back, send it to Lagos, change the fan, bring it back, we'll have spent like 12,000. So why don't we have envisaged that SS is fan only? I just put the fan. And when you are putting external fan, you put it on where there are perforations like this. Don't go and put your fan here. And don't use the fan to block the fan here. There's another perforation. Let me assume that this blowing fan, you now put another sucking fan. So as it's trying to blow in, it's going out. The fan will not even work at all. Let this one bring the air in. Let this one suck the air out. Or let this one bring the air in. Let this one suck the air out. Okay.
For your solution, did you remove the other fan that wasn't working?
We just left it there because we don't want to untie the old inverter. Because it's still under warranty there. At the moment you untie the inverter, you have already void the warranty.
So you just put it on the next time.
Understand? Donald, the job that we did at OD then before we change the inverter to 2.5 kV, what we do with the fan? The external fan we put there. Are you the one that put external fan there? Abi it's Afa. It's Timothy and Afa that changed that fan as well. Have you that fan that you did at the NYC staff house? Explain how you put the fan there. You are talking of it now. How do you connect the fan? Stand up now and explain to us. You are an Agana, we can ask you questions to answer us.
Come here.
I connected the fan, I tapped it straight from the
battery. Meaning that whether there is light or there is no light, or the fan will ensure that the board are cool at every point in time. Hope you guys get what I'm saying?
Yes, sir.
Because ordinary heat will make you think the inverter is not even working at all. And during time like this, season like this, they will not even have problem because the weather is cool. So the fan is really less. I've answered your question now. So let me now move on. We have something I've explained a little about VDC earlier. VDC stands for voltage direct current, meaning that the voltage that is coming or your battery is receiving. Most batteries have a standard volt of 12 volts. Except lithium batteries. Most batteries have a standard of 12 volts. Lithium doesn't rate in voltage. And your battery is not rated in amps, it's rated in amps hour. You can't say a battery that they will write 12 amps on it or 50 amps. They will put 50 amps hour. Let's now move to the VDC now. How do we connect? I'll give you assignments here. How many of you did my assignments? Who not do am? Just raise up your hand. If you not do assignment, coke, one coke. Do you do my assignment? Do you do my assignment? Where is it? Oh, yeah. Do you do it? Oh, yeah, let me see it.
I don't know now.
I'm giving you another assignment. That's what I'm asking. What's the assignment? What's the question?
Cable capacity and rating.
I will check it after the class. So this is the assignment I'm giving you. On a 4 battery, let me first draw it. Let me put this down. Everybody will need to move closer. And this close down. I said I want to hear deeply. Maybe towards the No. They normally write it there. Maybe 2 watts or 5 watts. They write the wattage there. If I have a battery like this, let me draw it there. I have positive and negative. I have another battery here. I have positive and negative. Like the battery will have to. Let me bring that battery out. That battery. Your positive is normally what? Hide that battery. Put that battery at this side. Your positive is normally red, and your negative will normally be black. Although this battery, can you see? If this is 12 volts now, if I want to achieve 24 volts, not these things. If you connect positive to negative like this, is series. And if you also connect negative to positive like this, is still what? Series. Anything that we call parallel, please spell parallel for me.
PAR.
Yes.
So when you connect positive to positive, it's parallel. And when you connect negative to positive, it's parallel. So I have two battery systems now. If I want this battery to be 12 volts, and the inverter here, let's say the inverter I have here is 12 VDC. How will I do it? I'll connect this positive to this positive, this negative to this negative. You guys will need to stand up and move closer. The positive here now, I will now loop it here, and the negative here, I'll loop it here. I already have my 12 VDC on two batteries. I don't need to do on one battery. Everybody know on one battery. Let's now shift.
No.
I should start from one battery. Someone should give me his notes today. On one battery, let me say this inverter, and I want to achieve 12 VDC, and this one battery, which is 12 volts, 12 volts, and this 12 VDC. I'm talking of VDC on inverter now. I'll connect positive to positive, negative to negative. If I still want to achieve on inverter 12, and I have two batteries, and I do it like this: 12, 12, positive, negative, positive, negative. And I've already told you that when you have positive connected to negative, what's that?
Series.
When you also have negative connected to positive, you see what?
Series.
And when we have parallel, is it double arrow or single arrow? Parallel should be double arrow.
Single arrow.
Parallel. Okay, that is there.
Positive to positive and negative to negative. So I want to achieve 12 volts on two batteries now. It means I'll connect this positive to the positive here, and this negative to the negative here. Then I will now carry this negative to the main negative here. When we get to cable, I will be telling you the difference between this cable and parallel. If we now have
Parallel.
4 batteries now, and we still want to achieve 12 volts, this is it. This inverter. We have we have battery 1, we have battery 2, let's say B2,
3,
B3,
B4.
We have positive, negative, positive, negative, positive, negative, and positive, negative. And we want to achieve 12 volts. We need to still connect all the positive together, and we still connect all the negative together. Although there will be some changes in the energy capacity, we'll talk about that one when we get to battery. We now carry this single battery positive here, and I can decide to carry my negative from here or from there. This single negative is still what? 12 VDC. Let me now move to 24 VDC system. You know that in 24 VDC, how many battery do you need as minimum? So if it's 12 volt battery, we have battery that are 2 volts, and the assignment that we give you guys, I'll give you on 2 volts, and I'll give you on 296 and 120 volts, depending on how the spirit led me. Depending on how the spirit leads me. So na devil they lead me before I be. Amaka, na devil they lead me abi. Okay, noted. Let me try this. So I have 2 batteries now, and I told you that when you are using parallel connection, the voltage is almost constant. That's why you see that when we are collecting positive, the voltage still remain 12 volts. But when you are using series connection, why the currents, the amps will be increasing. So as I'm connecting like this, the amps that is generating is increasing. Oga, you will need to buy your note too. Because later I will be checking your notes. Inverters. Next class will be Friday. So we have positive, negative, positive, negative, positive, negative, positive, negative. We have positive, negative, positive, negative, positive, negative, positive, negative. And when you are having plenty battery, one thing I normally advise, if you are still a starter, get a paper tape, label all the draw it like this, and label all the battery. Because there's one thing about battery, if you make mistake like this, and you go and spoil inverter of like 5 million. You know, I once had a call member, Copper Children. I never forget that. He's a confirmed electrician. But the day we blow an inverter like this, now 490,000, now 90K, we used to repair that inverter. Because during the time I used to pay call member 10,000 monthly allowance. For 9 months, he did not collect 1 copper because he made mistake. So if you know that the battery is getting too much, just get paper tape. You can label them 1, 2, 3, 4, 5, 6, 7, 8. As you are drawing it like this, you are following it. You are drawing it, you are following it. So that you not mix up the connection. And before you connect to your inverter, read it on your multimeter. The moment it's not reading in the range of 48, you should know that there is an error in your connection. Go and check. And it's better you do it perfectly from the beginning, and you make error along the way. Just imagine you are connecting 16 batteries. You will need to bring all the 16 down, back again, and start arranging it one after the other again. Can I move on now? You still connect this to this, this to this, this to this, connect this to this, this to this, this to this. I've already achieved 48 here, 48 here, because each of them are 12, 12, 12, 12, 12, 12, 12, 12. So this, I will now connect it to this, like this. This, I will connect it to this, and now connect it like this. So we have 8 batteries. 48 volts VDC system. So the assignment I'm giving to you now, we will do 48 volts, 16 batteries. You will do 96 volts, 8 batteries. You do for 16 batteries. And you do 32 batteries.
Oh, okay.
You use a complete side like this. No, I'm not. 12 volts is simple. No 12 volts assignment. All the batteries are what? 12 volts. The battery you are using for your design. Because I once gave that assignment like that, and that guy just said, "Oga, I just use lithium battery of 48 volts, and I joined two together from 90." You got it right now. So, provided that your batteries are what? 12 volts, then you now do 15. You assume that the inverter is 15 kVA, 120 VDC. So you are going to use 10 batteries and 20 batteries. So your assignment is number 1, this number 2, and this number 3. I'm only giving you 3 assignments. So before I finish the class, let me see your cable gauge. Yeah, those are these assignments of cable gauge. Bring it out.
I have question.
Yeah. Questions are welcome before you bring your assignment out. Okay, based on the drawing, you can snap or one group here.
That's why I
I'm
never
there.
see the class na time.
I'm there.
Chat me up to see Alem who is in the group. So Emma snap to share Emma to see for the group. Questions.
So this 48 VDC,
Yes, sir.
it can basically be used on 5 kV inverter, right?
No, most 48 start from 3.5 kV. There are some inverters that are 3.5 kV and 48. But the one we'll be doing this weekend is 3.5 kV, 24 VDC.
Okay.
But we will now be using 8 batteries or 4 batteries.
Then the 8 batteries can be used for 10 kV inverter.
Yes, it can be used, and it can be used on 3.5 kV as well.
Ah, wow.
Some places like government hospitals, they can have just. There's one bank in Isheyin. The inverter is 6 kVA for 120 VDC. Just 6 kV inverter, but it's using 10 batteries. They auction the inverter out. They have not been able to sell the inverter till date. Because I go have just 6 kVA, and I will now use 3.1 million to buy battery on top of. With such system, the moment the batteries are full, we use them on what we call off-site projects, where even if there is no electricity for the next 1 week, the battery are still running. They use them in banks. It might be 10 kVA, 120 VDC, 20 batteries. Some ATM machines, they are just 5 kVA, 120 VDC. Meaning that even if there is no sun, and it's an independent ATM machine, there is no sun for the next 3-4 days, the ATM is still working. And all what the ATM needs is just 5 or 4 kVA. So they put maybe 6 kVA, 120 VDC. But we don't use them in home music. There are some all the people that do aluminum sheets. Some of them have 30 kVA, 240 VDC. Meaning that the minimum battery you use there is 20 batteries, and some of them are having 40 batteries. We are still going to get to that later, where you have 3-phase system, so that at any phase, none of the battery is being overworked. So we are graduating from here. Against next class, I'm still talking on single phase. We move to 3-phase inverters. Any other question? No question. So in the absence of no question, let me say something. Okay. It's not possible. You need to make sure that the inverter is on. And one of the ways to test is that you remove the power coming in to make sure that the inverter is on and working. It's not you supply energy. Any other question? We are still coming to event inverters, solar inverter, solar polarity. We have 3 types of polarity in inverter. So later, so in the absence of no questions, let me see your assignment. What we call this class again? Oh yeah, everybody move closer. If you are on 4 mm,
When are you doing something for?
yeah, come closer. If you are using 4 mm, 4 mm can carry up to 60 amps. Original 4 mm. Let me. You will not go and buy 4 mm that when you check the gauge, you mean like 2.8 there. An original 4 mm can carry up to 60 amps.
Okay, this one is correct.
Oga, you don't make mistake. You don't already make mistake. I've already seen it.
Sir,
This one is
can I
wrong.
call the light?
Don't worry. This one make mistake. This one make mistake. Oh shit.